Let us discuss the hydrolysis of salts. That is the interaction of the cations and anions of a salt in water, with water. Okay, what is the type of interaction which happens when the salt comes in contact with water? Now, only those ions which come from a weak acid or base of the salt will undergo such an interaction. What does that mean? Say, for example, you have ammonium chloride. Ammonium chloride is a salt. Ammonium chloride comes from ammonium hydroxide and HCl. Okay, here HCl is a strong acid and ammonium hydroxide is a weak base. So in ammonium chloride, ammonia comes from a weak base and chloride comes from a strong acid. So here I have said the statement is only those ions coming from a weak acid or base of the salt will undergo such an interaction. So in case of ammonium chloride, it will be ammonia which will be undergoing such an interaction, or we should be undergoing hydrolysis. Alright, so in NaCl, both Na plus and Cl minus will not undergo any hydrolysis, will not interact with water. They get hydrated, they don't get hydrolyzed. The ions from strong acids and base don't get hydrolyzed, they get hydrated. Now the pH of the salt solution depends upon the hydrolysis of these ions. Okay, that's how, when we dissolve the salt solution, the pH of these salt solutions depends upon the hydrolysis of these ions. Whether the anions and cations are hydrolyzed or not. And hydrolysis of these anions and cations depend upon the from which acid or base, strength of the acid and base from which it comes. Now let us take the example of a salt from a strong acid and strong base. How does that hydrolyze, or whether it will hydrolyze? Now we have said earlier itself, hydrolysis happens only for the ions which comes from a weak acid or weak base. So here you are using a salt, you are taking an example of salt which we get from a strong acid and strong base. So the ions will be from strong acid and base. They will not undergo any hydrolysis. They will get hydrated. Say salt like NaCl, KNO3, etc. They don't get hydrolyzed. They get hydrated. So the solution will be neutral. So NaCl solution will be neutral. KNO3 solution will be neutral. Now we'll take example of NaCl. NaCl is a strong salt. It will dissociate to Na plus and Cl minus. If Na plus undergoes hydrolysis, it will react with form NaOH, and HCl will be formed. Both NaOH and HCl are again strong ions. They get dissociated. So H plus and OH minus ions will be released, so the solution becomes neutral. Now, if we take in the case of salt of weak acid and strong base, like sodium acetate, potassium cyanide, then you can have sodium carbonate, etc. Now what happens? Let's take these the ion will undergo hydrolysis. Which ion? The ion which has come from the weak acid. So in the case of sodium acetate, it will be the acetate ion which will be hydrolyzed, and the solution will be alkaline in nature. Let's see how it's becoming alkaline. Now sodium acetate will dissociate to acetate ion and sodium ions. Okay, and this sodium acetate ion, the acetate ion will interact with water to form acetic acid and OH minus ion. So this interaction with water releases OH minus ions. So the solution becomes alkaline in nature. Okay, and hence a salt of weak acid and strong base will form an alkaline solution. The pH will be above 7. Now the case of salt of strong acid and weak base, say like salts like ammonium chloride, ammonium nitrate, ferric chloride, copper sulfate, etc. Now again I repeat, the ion which comes from the weak base will be getting hydrolyzed. So in the case of ammonium chloride, So the ammonium ion comes from ammonium hydroxide and chloride ion comes from HCl. So ammonium ion will undergo hydrolysis. Now the solution which we get from a salt of strong acid and weak base would be acidic. How is that? Take the example of ammonium chloride. Ammonium chloride dissociates to ammonium ion and chloride ion. And the ammonium ion will interact with water to form ammonium hydroxide and H3O+. So H3O+ ions are generated. So the solution becomes acidic in nature. The pH will be below 7. Alright. Now the last case, that is the salt of weak acid and weak base. Now here, say example, ammonium acetate, ammonium carbonate, etc. Both the acid and base are weak, so both the ions come from weak electrolyte. So they undergo hydrolysis. The solution which we obtain from such a salt will be nearly neutral, or weakly acidic, or weakly basic. Now what happens? You take ammonium acetate. You get acetate ion and ammonium ion on ionization. Both acetate ion and ammonium ion come from weak electrolyte. Acetate ion come from acetic acid, ammonium ion come from ammonium hydroxide. So acetate ion will interact with water and ammonium ion will interact with water. It forms acetic acid and ammonium hydroxide. So these two, what do we say? They do not undergo complete neutralization here also. So there will be nearly neutral or weakly acidic or weakly basic. That depends upon the relative strength of this weak acid and base. So if acetic acid is weaker than ammonium hydroxide, the solution will be basic in nature. If ammonium hydroxide is weakly basic, less basic than ammonium acetic acid, then the solution will be acidic. So it depends upon the pKa value. Alright, so you can say the solution almost becomes neutral. So this is how the salt of different types of salts undergo interaction with water and give us different types or different solutions with various pH. So salt of strong acid and strong base gives a neutral solution. Salt of weak acid and strong base gives an alkaline solution. Salt of strong acid and weak base gives an acidic solution. And salt of weak acid and weak base gives us a almost neutral solution. Hope it's clear to you. Thank you.